In the previous section, we looked at multiplying a polynomial by a monomial. In this section, we're going to multiply binomials together, or polynomials together, and we're going to start with binomials. So let's look at how we would multiply two binomials, and we're going to do it using the distributive property to start with. If we have y plus 8 times y minus 4, I'm going to use the distributive property and multiply everything in the second binomial by y. So we're going to have y times y minus 4 plus 8 times y minus 4. And when we do that, we get y squared minus 4y plus 8y minus 32. Then we can simply combine like terms. Y squared plus 4y minus 32 is what we get when we multiply y plus 8 times y minus 4. I simply used the distributive property. Let's look at another. 2x plus 1 times x plus 6. Again, we're going to use the distributive property to start with. In a minute, we'll look at a little bit of a shortcut. But I'm going to multiply everything in the second binomial by 2x. 2x times x plus 6 plus 1 times x plus 6. And we get 2x squared plus 12x. Notice I'm distributing, I'm multiplying each of these terms by 2x, plus 1 times x, plus 1 times 6, combine like terms. Yep, this should be 13x because we have 12x plus 1x plus 6. Let me erase that to make it look a little better. So 2x plus 1 times x plus 6 is 2x squared plus 13x minus, plus 6. All right, let's look at another example. I want to do 5y minus 2 times y plus 8. We can do the same thing using the distributive property. I multiply everything in the second binomial by 5y. And then I multiply everything in the second binomial times a negative 2. So we have 5y times y is 5y squared, plus 5y times 8 is 40y. Now notice we are going to multiply both terms in the second binomial by a negative 2, minus 2y, and negative 2 times 8 is negative 16. So we have 5y squared plus 38y minus 16. So it's not a difficult thing to do. We want to look at a little bit of a shortcut version of the distributive property that is called the FOIL method. Some of you have probably heard of that before. FOIL, it means first, outside, inside, last. So if we look at z minus 6 times z minus 12. First means we're going to multiply these first terms together. Z times z is z squared. Notice then we said outside. we're going to multiply the two outside terms together. Z times negative 12 is negative 12z. Then we multiply the two inside terms together. Negative 6 times z is negative 6z. And then the last two terms together. Negative 6 times negative 12 is a positive 72. So we combine like terms, z squared minus 18z plus 72. Notice I put the little line through my z so I for sure know it's not a 2. So really that's the distributive property. It's just a little bit quicker way to use the distributive property. Let's just do a few more like this. Remember we said first, outside, inside, last. So if I have x plus 3 times x minus 4, we're going to multiply the first two terms together. X times x is x squared. Then we multiply the two outside terms together. X times negative 4 is a negative 4x. Then the two inside terms together, plus 3x. And then 3 times negative 4, the last two terms, negative 12. And we get x squared minus x minus 12. Actually, it's just a different way to use the distributive property so that you don't have to rewrite that problem. You can just go straight to your multiplication without rewriting. Let's look at another. 5a plus 2 times 3a minus 4. Move this up just a little bit. Remember, first terms together, 5a times, I'm sorry, that's not the first terms, is it? Let me move this over. 5a times 3a is 15a squared. The two outside terms, first outside, negative 4 times 5a is negative 20a. The inside terms, plus 6a, and that's a 20a. Negative 20a plus 6a, and then the last terms, minus 8. So we have 15a squared. Negative 20a plus 6a is negative 14a minus 8. Okay, I want to do one more example like this. We have 11z minus 5y times 3z plus 2y. Again, we have two binomials that we're multiplying together, and whenever you have two binomials, you can always use the FOIL method. So I multiplied the first terms together, and we get 33z squared. Then we multiply the two outside terms together, and 11z times 2y is plus 22 yz. We usually go in alphabetical order, yz. Then we do the two inside terms. 3 times negative 5 is negative 15, and then we still have yz. And then the last terms together, negative 10y squared. So if we combine like terms, 33z squared, 22yz minus 15yz gives us plus 7yz minus 10y squared. So these are examples of using the FOIL method, first, outside, inside, last, and it will always work when we are multiplying two binomials together. Now let's look at what happens if we multiply a binomial times a trinomial. Can't use FOIL for that. So let's look at an example where we take a binomial and we multiply by a trinomial. Let's look at 3x minus 5 times 2x squared plus 7x minus 8. Okay, on this one we cannot use FOIL, so I'm just going to go back and use the distributive property like we did on the first problems. We're going to multiply 3x times everything in that trinomial, 2x squared plus 7x minus 8. And then we're going to multiply all of that by a negative 5 times 2x squared plus 7x minus 8. And yes, you do have to rewrite it like this so you can see what you're doing. So we have 3x times 2x squared, which is 6x cubed. 3x times 7x is 21x squared. And 3x times negative 8 is going to be a negative 24x. And notice I have to multiply this by a negative 5. So negative 5 times 2x squared is a negative 10x squared. Negative 5 times 7x is a negative 35x. And negative 5 times negative 8 is a positive 40. Now I can combine like terms. We have just one 6x cubed. We have 21x squared and a negative 10x squared. Okay, I've used my 6x cubed. 21 minus 10 is 11x squared. Kind of marking them out so I don't forget anything. Negative 24x minus 35x. If we add those two together, we get 59x minus 59x plus 40. Now we have this in the standard form. Notice it's in descending powers of x, and I've used everything that we have there. Okay, now we go through the similar procedure if we multiply a trinomial times a trinomial. It just takes a little bit longer. If we have m squared plus 2m minus 3 times 4m squared minus 7m plus 5. Okay, I'm going to take each term in the second trinomial and multiply it by each term in the first trinomial. So we're going to have m squared times the trinomial 4m squared minus 7m plus 5 plus 2m times 4m squared minus 7m plus 5. And I'm running out of room, so I'm just going to move it down a little bit. Minus 3 times 4m squared minus 7m plus 5. Now let's distribute. M squared times 4m squared is 4m to the 4th. M squared times negative 7m is negative 7m cubed. And m squared times 5 is plus 5m squared. Just keep going. 2m times 4m squared is plus 8m squared. M cubed. 2m times negative 7m is negative 14m squared. 2m times 5 is 10m. Negative 3 times 4m squared is negative 12m squared. Negative 3 times negative 7m is positive 21m. And negative 3 times positive 5 is negative 15. So we've got a lot here. You need to be neat so we can work through and combine like terms. There's only one m to the fourth, so we start out with 4m to the fourth. Okay, we've taken care of that one. Notice I have 2m cubed terms. Negative 7m cubed plus 8m cubed is going to be 1m cubed. So those are used. I have 3, let me go to a different color here. 3m squared terms. So 5m squared minus 14m squared is negative 9m squared, and negative 9 minus 12 is negative 21m squared. All right, negative 21m squared. Then, okay, so I've used those. Now I have 10m plus, plus 21m is 31m. Now those are used. Minus 15, 31m minus 15. And it just took a little bit longer, but using the distributive property and taking it step by step, we got to, we multiplied those two trinomials together. FOIL is easiest, since that's just two binomials, but you can always use a distributive property, even with two binomials. FOIL is just another example or another method, a shortcut to the distributive property. If you're multiplying a binomial times a trinomial, you'll have to use the distributive property. And same thing if you're multiplying a trinomial times a trinomial. You'll have to do what we did in this problem. Separate it out, multiply each term in the first trinomial by every term in the second, and then combine like terms. All right. Your assignment is assignment number 9. And it's on page 483. And you have 2 to 28 even. And you may omit number 24. Okay. Page 483, 2 to 28 even, and you may omit number 24.